All right, so here we have the review sheet for the summative, which is on Thursday. Here's the key for that review. All right, so the first part, we have a function f of x equals 3 to the x power. We're going to put these x values in for x and find out what they give you. So 3 to the negative 2 is 1 over 9. 3 to the negative 1 is 1 over 3. 3 to the 0 power is 1. 3 to the first is 3. And 3 squared is 9. When we plot these points, I'm not going to plot the fractions. I'm just going to plot the other 3 points. So we have 0, 1. We have 1, 3. We have 2, 9. If we graph it, it's going to look just like this. Okay. For the inverse, all we're going to do is we're going to take the values in our table and reverse them. So now instead of the y's being 1/9 and 1/3 and so on, those are going to be the x values. So you have 1/9, 1/3, 1, 3, and 9. And then the x values of the previous table become the y values of the next. -2, -1, 0, 1, and 2. Okay. If we plot those points, again, I'm only going to plot the integers or the whole numbers. So you have 1, 0. 3, 1, 9, 2. Graph this equation, and there we go. So those are your two graphs and the table of values that make up the graphs or the equations. Okay. All right, next we're going to do the characteristics. We're just going to go back and forth, domain for both, and range for both. Okay, so that helps you hopefully see the difference between the two as we go along. All right, for the first part, I'm going to do this in red so it's a little bit easier to see. For the first one, domain. Domain is going to be the values that exist in the graph, the x terms that exist in the graph going left and right. So starting on the left, our graph goes all the way to the left. So it starts at negative infinity, and as it goes to the right, it keeps going to the right, so it's going to go to positive infinity. For our inverse function, right, as it goes to the left, it kind of gets stuck at the y-axis, so it never gets past 0 on the for the domain. On the left and on the right, as it goes all the way towards infinity. So that's your domain. So think about the domain as what x values exist in the graph. Okay, there's no x term. There's no x value of, like, let's say -6 comma something for this equation for the inverse, because there is no x value that's less than 0. Okay, that's not even a 0 x value in this equation. It gets close to 0 whenever it actually touches it for the x terms. All right, so for the range is going to go from the bottom to the top. All right, for the first graph, the f of x function, all right, what y values exist for this function? Well, nothing goes below 0. So we're going to have 0 at the bottom, and it's going to go up towards positive infinity. All right, as opposed to the inverse graph, that starts at negative infinity at the bottom and works its way up to positive infinity at the top. So for range, it's the y values that exist in the graph. Okay, for your asymptotes, this is where it's like an invisible boundary for your graph. So for the f of x function, it never goes past the x-axis. So that little equation of that dotted line, it's going to be y equals 0. No matter what x is on the graph, y will always equal 0, and that's the equation for it. Or sorry, that's the graph for that line. All right. For the asymptote of the inverse function, this graph is never going to cross the y-axis, and the equation for the y-axis is going to be x equals 0. So no matter what y is, x will always be 0 for that equation and for that line. Okay. X-intercepts. So where does the graph cross the x-axis? Well, because the asymptote is on the x-axis, this never crosses the x-axis. All right. As for the inverse function, it crosses the x-axis at 1, 0. All right. For the y-intercept, this does have a y-intercept where it crosses the y-axis. It is at 0, 1. But for the inverse, the asymptote is on the y-axis, so there is no y-intercept. All right, next, intervals of increase and decrease. Well, the first graph function is going from low to high, so it is increasing. And it's increasing over the entire graph. So that means over the entire domain, and so we're going to write down the domain. So negative infinity to positive infinity. That's where it's increasing. Over the whole graph is increasing. For the inverse function, you got the same idea. Over the whole domain, it's going up the entire time. Okay, but its domain is smaller. So when it's increasing, it's going over a smaller domain from 0 to infinity. Okay. And lastly, the end behavior. So we look at the first function. As x goes to the left towards negative infinity, what is the graph doing on the y values? As the x goes towards negative infinity, y gets closer and closer to 0. It never crosses 0, it just gets closer and closer to it. As the graph goes to the right towards positive infinity, so as x approaches positive infinity, the f of x function approaches, well, the graph is going up towards positive infinity. So as it goes to the right, it goes up. For the inverse function, as the graph goes to the left, what does it go towards? Well, normally you'd say negative infinity, but this graph doesn't go towards negative infinity because it's stopped by the asymptote. So this graph goes approaching 0. And as it approaches 0, what is the function going to do? It's going to go down towards negative infinity. And as the graph goes to the right, so as x approaches positive infinity, what is the inverse function going to do? It's going to go up towards positive infinity. And that is the characteristics of each of these functions. Okay. Now let's do some practice with changing exponential equations to logarithmic equations. Okay, there are some patterns you can discern from these. Okay, the first is that the base of the function is always going to be the base of your log, and the exponent of your function is always going to be your answer, in a sense. It's going to be what the log equals. So we have log base 3, both bases are 3. All right, 27 is what the log is of, equals x, okay? So the x value is always going to be, or sorry, not the x value, but the exponent of your equation is always going to be your equaling value. For part B, the base of your exponent is 1/3, so you're going to have log base 1/3 of 27 equals x. Again, the exponent becomes what the log is equal to. All right, here your base is 2. Log base 2 of x is equal to 7. Again, your exponent becomes what the log is equal to. And then finally, here's your base. So you have log base 27 over 3 of 5 over 9 equals x. Again, your exponent is what your log is equal to. And your base becomes the base of the log. Okay. All right, we're going to look at another example of the graphs and functions and inverse functions of an exponential equation. So again, we do our table of values. So our function is f of x equals 1/3 to the x power. So if x is -2, okay, your function is 9. So 1/3 to the -2 power is 9. 1/3 to the -1 power is 3. 1/3 to the 0 power is 1. 1/3 to the first power is 1/3. And 1/3 to the second power is 1/9. So again, I'm going to grade just the whole numbers or the integers and not the fractions. So we have -2, 9. We have -1, 3. And 0, 1. So our graph should look like this. Another couple things to note about this equation. Notice it's decreasing because the base value there is greater than 0, but it is less than 1. So because it's a fraction, it's decreasing. Okay, so now, just like before, we're going to take our table of values and switch them, flip them from the y becomes the x. So we have 9, 3, 1, 1/3, and 1/9. and our x's become the y. So -2, -1, 0, 1, and 2. Okay, again, I'm going to graph these based on just the integers and not the fractions. So we have 9 and -2. We have 3 and -1. We have 1, 0. And then what is happening is it's going up. Or actually, it's not going up. It's decreasing. But it kind of looks similar to the previous one. Okay, so let's look at our equations for this. Or sorry, our characteristics, my apologies. All right, so for the domain. All right, so the x values from left to right. So all the x values exist, so we've got -infinity to +infinity. For the inverse, all right, now for this one, again, as the graph is going down, it's being stuck by that y-axis. Okay, so it can't go past 0 on the x-axis. It can't go past the y-axis. Okay, so that means it's going to be going from 0 to +infinity. For the range, all right, for the first graph, the f of x function, the graph will not go past 0 on the y-axis, so it won't go underneath the x-axis. So its range is going to be from 0 to infinity. All right. Now your range for the other graph, the inverse function, from bottom to top is going to keep decreasing, and it's going to go all the way up. So it's going to be from -infinity to +infinity. All right, just like before, I'm going to actually change colors again to show you the asymptotes. So there's your asymptote for the regular f of x function, which is going to be y = 0. And for your inverse function, your asymptote is going to be here on the y-axis, which is the equation of x = 0. Kind of like blue a little bit better, so I'm going to stick with blue as my color here. X-intercepts. So since the first graph, the f of x function does not cross the x-axis, there is no x-intercept. However, the inverse function, it crosses at 1, 0. For the y-intercept, all right, the f of x function crosses the y-axis at 0, 1. And the inverse function doesn't cross the y-axis at all, so it's going to have none. So intervals of increase or decrease. Well, in this case, this function is decreasing. All right, and it's decreasing over the entire domain. So the whole thing it's always decreasing. It's going to go from -infinity to +infinity. All right. For the inverse function, again, this function is also decreasing. And it is also decreasing over the entire domain. From when it starts at 0 and going towards infinity, it's always decreasing. And lastly, the end behavior. So as this graph goes to the left, as this graph goes towards -infinity, what is it doing? It is going up towards +infinity. All right, as the graph goes to the right, towards +infinity, what is the graph doing? It's getting closer and closer and closer and closer to 0. For the inverse function, as the graph goes to the left, well, it can't go all the way towards -infinity because the asymptote's in the way, so it's going towards 0. And as it goes towards 0, what is it doing? It is going up. You can see the red graph is going up as it gets closer and closer to 0 on the x-axis. All right. As the graph approaches +infinity going to the right, what is it doing? It's going down. It's going down. Oh, forgot the little -1 sign there. It is going down towards -infinity. Oh, that's an ugly infinity sign too. My goodness. There we go. Okay. Now, kind of like before, where we did exponentials to logarithmic, we're going to go backwards this time. The logarithms are going to become the exponentials. Okay, and it's going to be the reverse process. So the base of the logarithm is going to be the base of the exponent. So we have 3 to the 8th equals 6561. All right. Again, the base of the log is going to become the base of the exponent. So 5 to the 9th power, 5 over 9 to the 4th power, equals x. All right, this doesn't have a base on it. So that means if it's a log that has no base, that base must be a 10. Okay. Raised to the 4th power equaling x. And with this case, the ln means it's a natural log, and a natural log has an e. So it would be e to the x equals 6. And those are your equations. Those are your exponentials from a log. Okay. Moving on. Okay, this is asking